We're live! Yay! Hello, beautiful humans. Welcome to Teach Jenn Tech. And today we are learning Teach Jenn Snowflake with Anthony. Anthony, who are you? And what do you do?
Hi, Jen. Thanks for having me on. So my name's Anthony Schneider. I'm a solutions engineer at Snowflake. So I've been at Snowflake for about 7 years. So I work in the pre-sales department. I talk to a lot of customers about our data platform, how it works, and yeah, a little bit about data warehousing and data lakes in general. Before joining Snowflake, I actually worked at a company called Nectar. If anyone's been to the UK, if you go into one of their largest grocers there and swipe your card, you get points, loyalty points back. So I worked in the data platform team there and did a big move of their on-premise environments into the cloud. So I've got a bit of that experience from the customer side as well.
Very cool. And yes, for anyone curious, we actually met when I was in Australia last month at Data Engineering Bites at Melbourne, where I gave my first big tech talk. It was awesome and very nerve-wracking. Very excited to have it done, and I'll do another one someday. But while I was there, people like Snowflake were there and ClickHouse, and I was like, I should probably learn more about what things outside of my past employer was offering, because I was like, data is huge and there's so much data. And thank you, Anthony, for being so kind and being willing to be on the show, because I was like, I don't even know what data warehousing is or data lakes. And people ask me about it all the time. And I'm just like, it's a thing. It's a thing that happens, and that's as far as I got.
I get that all the time. And that conference, by the way, is full of data engineers and they're very technical. So you don't feel at all lost if I get lost in conversations. It's a very good conference, but it's certainly one where the highly technical people attend. And I get that same thing from my family. Like if I say, I work in the data warehousing space, I just get that blank stare, like data warehouse,
I try to tell people what I do, and they're like, "You what?" And I was like, I work in tech. That's what I tell them now. I'm like, I work in tech. I work with software developers. That's what I do. And they're like, "Oh, okay."
No follow-up questions, right?
Exactly. But for us to get started, if you're talking to somebody that has no idea what data lakes or data warehousing or anything like that is, do you have a good way of explaining what Snowflake is and possibly how a company would use Snowflake, or what kind of company would use Snowflake?
Yeah, sure. That's a good way to start. I think the first thing I'll say about the terminologies, I find this space quite strange, and I've been in it for 15 years. People are quite emotive over terms and terminology, and if you say this means that, some people get a bit upset, which I always find interesting. But sort of the way to think about data warehousing and data lakes. Data warehouses have been around for a long time. So data warehouse, and the key thing I'll say is that, and my company is as much to blame in this, a data warehouse isn't a piece of technology. Data warehousing was an architectural pattern that was brought in, I think it was back in the 70s or the 80s. The idea there is
Okay.
that you have a physical warehouse that right, that has products, and you organize those products so that when you need to ship them out to the stores, they're easy to find. And the same concept goes for a data warehouse, except replace those products with data. So it's about organizing your data onto virtual shelves in a platform and making them easy to consume by the people in the business that need to ask questions of that data. That's what data warehousing is. And that's kind of where Snowflake fit in to say, we are the best platform in the cloud to achieve that, to manage that data, to get it all into a place that people can consume it easily and ask questions of that data. So our marketing was Snowflake, the cloud data warehouse, which, the real tagline should have been the best platform to implement data warehousing architectural patterns, but that didn't quite have the marketing ring, right? So that's the marketing department's fault. I don't blame them. But that's where some people say, well, you're not a data warehouse, you're a data platform. So that kind of sort of answers what Snowflake is as well. We refer to it as a unified data platform that makes bringing data in very easy, managing and securing that data very easy, and consuming that data or interacting with that data very easy. And in the past, that's been something, particularly on-prem, that's really quite hard to do, and very expensive is the other component.
Right. So if I'm thinking on this of I I like to find parallels with the tech, and I think a lot of other people do this too. If you think of a warehouse, a lot of times, yes, it can have something that's just stored there, but a lot of times it's where something gets stored and then picked up. So it again doesn't store anything long term. It's a way to flow things. So that makes sense. Um, and I think also something that I realized from that conference is there doesn't seem to be a way to say data architecture is the same everywhere.
Mm.
Like kind of like building architecture, if you go to school, they like no matter where you are in the world, they will have the fundamentals.
Yep.
And but with data architecture, it seems like there's a lot of differences. So as you were talking about the phrasing and how each company may or individual may do it different, um, how do you see that kind of making it a struggle to understand people's needs, especially when we could be talking using the same term two different ways?
In terms of data architecture and the patterns and the
Mhm,
differentiation, how people do it differently. I think it's a really good point, and I think a lot of people that come new into the industry and are trying to understand how to move data through the various stages to a data warehouse struggle with, and that's because there's no defined pattern. And I can say this because my wife's German. She loves a bit of structure, right? You love to say this is exactly how you do it, and this is the end result. Think of it as a physical warehouse and everyone had the exact same floor plan for their warehouse. That would be great, but that's not really how it works. So what there are in the industry is there's some leading sort of patterns at a high level as to how you bring data from source through to the end layer, which would classify as the data warehouse. So a few terms that would have come up at the Data Engineering Bytes conference were around probably medallion architecture, or storing data in a raw layer and moving it through to what we'd say is a conformed layer. It's all about, in the old days, in old data warehousing, there was a thing called ETL. Have you come across ETL and ELT, Jen?
not yet. Not that I remember. I'm starting to take notes for this right now.
So ETL stands for extract, transform, and load. And back when I started, I'm getting a bit old now, everything was kind of ETL. And the reason for that was that the data platforms couldn't scale easily, right? In the
Mhm,
on-premise world, if you needed more compute, you needed to call up someone who'd stick a physical server in the on-premise center. And that was usually a 6-month project. So the idea that I need a huge amount of compute to do this transformation on this data, that didn't exist in the old world. So what we used to have was we had this ETL pattern. And I'll give an example in my world of retail. Let's say we have transactions coming through from a store. And there's a few erroneous transactions that are like dummy data, we'll call it. So you get these transactions coming out of the till when you swipe your card. That comes out in a file that we pick up and bring into the data warehouse. But some transactions have a date of the year 1900. We need to
mhm.
cleanse that, that's called. In the old world, you'd do ETL, right? So what that means is you'd extract from the source system, the till, you'd bring it into, in our example, Snowflake. You'd transform, as in do that transformation, which could be a cleanse, which is a exclude all records where date equals 1900. And then you'd
Mhm.
bring other records into the data warehouse and you'd start to do more transformation on those. So that's extract, transform, and then load into the data warehouse. The huge
Okay,
problem
that
with,
makes
and the way that the industry's changed is, what if someone, let's say a month later, said to you, Oh, Anthony, we messed up. Those 1900 records, they were actually from the 26th of February, but some idiot in the source system made a change which broke the records. Me as the data engineer, I'm kind of messed up then, because I've transformed, dropped them, and those records, for all I know, depending on how the source system works, are gone into the ether. So I could have lost a whole bunch of records that were actually real transactions from real customers that I need to perform analytics on the other side. The reason the industry now has moved to an ELT pattern. So what that means is I extract all those records, I load them into Snowflake, and then I transform. So in the same scenario then that person down the other end says, those 1900 records, Anthony, we need them back quickly. I don't have to go back to source systems or anything. That raw data is sitting in Snowflake in that layer that I talked about, that bronze layer or the raw layer. And I can quickly go back and go, find me all the records that came in on Tuesday, 1900, and bring them into the system. So it allows you to kind of go back, and that's just one reason why the pattern's very good. And that's from my background as a kind of support engineer for data warehousing, is that it makes sort of fixing errors and maybe grabbing new data a lot easier than going back to source systems, because some companies have thousands of source systems, right? So it can be very tricky to sort of get that back. So the reason I mention ETL and ELT is that medallion architecture, or that pattern of storing data in its rawest forms, that's where the industry is moving. And that's where platforms like Snowflake accelerate, because in my old platform, it used to cost, I think it was about $40,000 to store a terabyte of data. So
Oh, wow.
you had to make really difficult decisions about what data to store in that layer, right? Because, maybe I need those 1900, maybe I don't. Storing those 1900 records is costing the company, $1,000 a day. Whereas these days it costs, I think it's in Australia, it's $26 a terabyte for compressed data. So you don't have to make those hard decisions about what data. It's kind of like, I'll keep the data there just in case it's needed. It just allows you to be a lot more flexible in what data to store and what data to sort of throw away.
Interesting. And thank you for mentioning like terminology that was at the conference too, because I wrote that down to go back and look into as well. I feel like that's going to cause some rabbit holes later on. Yay. And that is one thing with data, like just tech in general. There's just so much to learn. It's never ending. And to take a step back, we mentioned on-prem. And I remember when I first took my first job at a startup, I was like, what's on-prem? I was so embarrassed to ask. And you mentioned, no, you mentioned that like something on-premise, which for a lot of people that would have clicked. But I was like, I didn't realize, and I think this is something for individuals maybe new to tech, or I would say maybe even younger individuals, it may not be as much of an experience of seeing so many things with like the actual hardware being on-prem somewhere. Because so much of the world is in the cloud now. But even the clouds technically are on-prem somewhere. They have they have their
You're right. Yep.
they have their data warehouses somewhere. But now, what is a data lake?
Data lake, yes. So a data lake, again, is a pattern. To use my real world analogy, you've got a lake, it's got water in it. The clouds are the source systems in my example. So you've got the tills at the supermarket, you've got the product catalog over there, and you've got the customer database over there. So they're the clouds. They've got a whole bunch of data in them that they're dropping, and they're dropping them into the lake. So the water in the lake is the data. So the problem with data warehousing was getting the data out of those clouds and bringing it into the data warehouse. There was a small little pipe, and that pipe consisted of technology and individuals like myself, data engineers. And we used to just get overwhelmed. That pipe could never fit enough of that data. So what used to happen was someone would say, there's a new system that we need to get data out of. They'd go to my team and say, how long till we get that data? And I'd say, it's probably about 8 months I can get you that data. And that just doesn't work for companies these days, right? If you're doing a new project, let's say you're doing a new campaign, so there's a new campaign system, new data comes in, you pretty much need that data straight away. So the idea behind the data lake, which was championed by these open source technologies. Open source is obviously kind of free to use. There's no commercial element to it. So a term Hadoop that people would probably be familiar with was about allowing that data to flow into a storage area without the pipe, right? It could just flow in naturally into that. And similar to what I was saying before in that pattern meant that you could start consuming that straight away. The biggest problem that had was, the technology was very complex, so it didn't really work. Only the Facebooks and Yahoos were really using it successfully. And this is my naive moment. I was a data engineer back then in data warehousing. So all I knew was the pipe way of bringing data in. The data lake thing, I'll be honest, scared me. I thought I was going to lose my job because I was like, you mean data can just magically flow out of the source systems into a data lake and then everything's done? What's my job then? And it's further compounded by people in the industry who say data warehousing is dead. So I'm gonna express a gripe there to say, data warehousing is not dead. The concept of managing data and bringing it out so that it can be used is very much not dead. We all have jobs. So sorry, I've gone a long roundabout way, but the data lake is about allowing data to easily flow into a platform like Snowflake or Hadoop in those days and start to consume it immediately. So it stopped that bottleneck. And then you still need to bring it out of the lake into somewhere which can be consumed, which is often referred to as the data warehouse.
Okay. No, it's weird because like what you said about a data lake makes sense, but it made me think more of like a freeway, even though it's called a data lake, of if data is moving so slowly, then like it's going from like a single lane road to like uh like a 10 lane freeway. So it's much faster. It's kind of what I was picturing for a data lake, but I was like, that doesn't, it's called data lake for a reason because it's not a river, it's instant. Oddly, this is what kept like I get stuck on in tech is like the naming conventions. I do think it's one of the hardest things in the world. But if I am understanding this correctly, and also, what up, Rivet and T Robbie Rob? Hello, welcome. Ask us all the Snowflake questions, or data lake, or data warehouse questions, or data questions in general. But for data lakes, it's where people can get things, the data instantly, instead of having to wait for it for so long. Like you said, at one point, people would have to wait 8 months, and now they can get it instantly.
Yeah, and the reason that is though is if I take the example of the same data, let's say I have data from a product catalog, right? A product catalog has an identifier for the product, it has a price for the product, and it has a name for the product. In data warehousing, I might need to do things like cleanse it, as I said before. I also need to put certain data types into certain fields. So the price is a decimal. So I need to, in my data warehouse, do a thing which is define a table with a data type, which is a decimal. And there's good reasons for that, because you get performance by just designing a data warehouse with data types and creating joins and things like that we can get into. A data lake doesn't do any of that. So there's nothing upfront to do. It'll take the product catalog, and that may be a CSV file, or it may be directly out of an API that comes out as a JSON format. What that basically means is that you don't do any of the manipulation of the data. You just drop the file into a file storage area. So that has some benefits, but it's not like Jen, who works in the marketing department, can use that. Like Jen needs specialist skills to use that raw file, right? You can't just grab a file of a whole bunch of products and say, and you may ask a question, which is the most expensive product in our catalog? How do you ask that question? That's where you need a platform like a Snowflake or something to be able to write a query against it. So, but there are a whole bunch of people that have the skills and the tools to use that raw file. So the idea is that the data lake makes that available to them. Data engineers, typically myself. Whereas in the old world, I had to go speak to the product catalog team. Whereas now I've got it all in my data lake, and then a new project comes up and they say, Anthony, we're doing a new project which is about product promotions. I need to see all products that were created in the last 2 years. Even if that's not in my data warehouse, I've at least got it in the lake and I've got somewhere I can go to immediately to grab it. I don't have to go to the
Okay.
product log team or the source system to get that.
That makes sense. I would say a follow-up question that just popped in my head is standalone, the data lake and the data warehousing is starting to make sense. But where would something in somebody's data pipeline, and of course, like somebody's tech stack is going to be so different based on their needs. And I do have questions about that. But before I go into that, like if where if somebody was storing their data in like Postgres or something like that, would that be like pre data lake? But also like if somebody wanted something like Kafka for real time, is that like a competitor of stuff like those are some tools that I've learned more about that I'm like curious where they would either fit into the tech stack or would replace certain things would be replaced.
Yeah, you're right. There's so many terms, aren't there? Postgres is a DBMS, so a database management system. And Postgres and these types of databases are typically used for what we would refer to as operational workloads. Another term to throw at you is OLTP, online transaction processing. So if we talk back in our retail landscape, you're an online retailer and you drop items in your shopping cart and you purchase items. That's a real-time use case or an online transaction use case. So when you leave the website and come back, you need to see your cart still, or you need to see your order history. And that's got to be real time. When I say real time, we're talking milliseconds. You can't drop something into your cart and wait 3 seconds, right? And I'll get onto why that doesn't work for the analytical workload side. But so what Postgres is typically used for, most small organizations start out building their website, their e-commerce site, and they need that fast online transaction processing system, which is Postgres, MongoDB, Oracle. Like there's a lot of databases that support that. So they're often a source system to Snowflake or to any of the other platforms that play in our space. But what typically happens is a small company starts out, a startup starts out, they start using Postgres for their online transaction processing. And then someone asks a question later and they say, oh, what were my highest products? So what they do is that's a SQL database platform. So you can write that in Postgres and you can answer that question in Postgres. So they answer it and they say, oh, great, I've got an answer. What happens is as the business grows, the volumes grow and the questions being asked of that data grows, Postgres quickly finds its limits, right? So it quickly kind of just starts running too slowly. And the other huge problem is if you're asking historical questions like that against your real life online transaction system, you have the potential of slowing down the people who are interacting with the website. Mm-hmm. So that's when a company needs to grow and say, oh, you know what, I need to separate out my transactional system that supports my website, my e-commerce here, to a data warehouse or an analytical, what we call it OLAP, online analytical processing. So that is that it needs to move to a separate area that won't impact the website and has the power to ask even more complex questions. Because what's my top selling product is not a complex question. An operational system can solve that. But what are my customers buying? Or let's say web analytics, where are customers clicking on my website and where are they getting lost in my website? That's a really heavy analytical question. Because you imagine if you're a popular website, people are making 100 clicks in a session times 1,000 customers, you're getting millions of records per day potentially that you have to sort of wade through to answer that question. So that's kind of where Postgres and that fits in. It's often a source. You can implement a data warehouse on Postgres, but it quickly finds its limits. And that's where people move to platforms that are designed specifically for what we refer to as analytics or historical analysis, which would be a Snowflake.
Got it. How about a Kafka type item, which isn't analytics from what I
Yeah,
remember.
Kafka's for stream processing. So, and this is the thing that you've asked there. There's overlap with all these products, right? As I said, you
Mhm.
can do data warehousing in Postgres, so you can understand how it's confusing. But Kafka's a stream processing engine. So the idea there is it's very commonly used in the transport industry. If you have a trucking company that has thousands of vehicles in the roads and you're capturing the GPS of where that vehicle is in real time, that's something that needs to be handled very quickly and with very low latency so that you can see where all your trucks are. And that's something that Kafka as a stream processing engine or a message queue is able to handle that very easily. You may have thousands of trucks at the exact same time needing to push that information somewhere. And Kafka is a good engine to handle that stream. And it can also do things like process. So if you need to quickly say, if a truck goes into this area, send an alert, Kafka is able to do that processing itself. Now, again, you could do that in Postgres and you could do that in Snowflake, but it's whether you get, like, you have very low latency, which means very quick response times from Kafka. It's really good at those, what we refer to as streaming use cases. So we often see Kafka as a source into Snowflake as well. So in my example, your thousands of trucks are pinging their GPS location. Kafka's consuming that and being able to have that data. But then when I want to ask really complex historical analysis questions of that to say, this truck driver is taking longer than that truck driver. I want to, have a word to the truck drivers who are taking longer on routes that others aren't. That question would typically be asked in Snowflake. That's not a question you would ask to Kafka, those complex
Okay.
analytical questions, right? Or if you
Interesting.
need to join the truck driver, the truck GPS information with the truck driver information to see, are my older drivers slower than my younger drivers? That data about my drivers is typically in Snowflake. That wouldn't be in Kafka, right? So the joining of data is something that Kafka doesn't do particularly well either.
Okay. And thank you for answering the comparison questions, because this was a very hard thing for me to accept when I first started this stream. Was we as humans naturally use comparisons that we already know to learn and kind of evolve from there. And so this has been really helpful. I do like how you mentioned that Snowflake joins the information. And another data type that I don't th I'm curious if it overlaps somewhere of things that Snowflake does, as well as something like Grafana, because Grafana does, like, really great visualization of data, but doesn't always, like, join the information together from what I understand. Does Snowflake do anything like that where it can also visualize a lot easier?
Yeah, I don't know Grafana as well, but visualization's a component. Often when people are asking questions of data, they need the visualization associated with that. So, in my platform, when I do demonstrations, I'll leave the AI part out of it and we'll write the SQL rather than ask the natural language question, although that's in there. So if I had my question there, which was, show me all the drivers who are along this route who have taken longer than an hour. That could be formulated in a SQL query. So I could do select driver name, hours taken from driver table and location table. All that's going to bring back is a set of numbers. It's going to have the driver ID and the number of hours they took. And then Snowflake within it has a visualization component, which I would click on the chart button in Snowflake, which would then show me a bar graph of the slowest driver to the fastest driver, I guess. So that's what people would refer to as business intelligence products. So we do have a lightweight one in Snowflake's UI, but it's probably not our foundations. That's what wasn't where we were born. Typically, what people do is they use something like a Tableau or a Power BI. So those tools ask the questions of Snowflake, formulate the SQL that I just wrote manually there, and then bring back the visualization. So they're the visualization component that often works as a partner technology to a data warehousing platform, which would be Snowflake or any of the others. But
Interesting.
yeah, there are a lot of platforms that aren't good at joins. And those use cases, tend to be those real-time use cases where everything's in a big fat sometimes people refer to it as a sausage table, right? So you've got a transaction at a store happening, and every other field on that says Anthony's the shopper, this is his gender, this is his age group, this is his affluence. That would be in one table. And some platforms are very good at hitting that. But that's not the reality of how data is managed in real world, because what if Anthony drops out of that age group? Do I update that record when he shopped 2 years ago when he was in that age group? Or some people want to know what my age group is now for my historic. All those complexities are where a data warehouse tends to store things in different tables. And we have Snowflake customers that will ask a question of the data that requires joining to 50, 100, or 1,000 different tables. And being able to do that efficiently so that you're not... I'll do a story from the old world. We had something like that in retail analytics where Pepsi or Coca-Cola wanted to ask a question of the data. And let's say Pepsi was saying, in the UK, where are my biggest regions that my sales are happening? And my competitors, which would probably be Coca-Cola, where are their biggest regions? Because I want to run a marketing campaign to try and capture some of their sales. We used to have a product that would allow Pepsi to ask that question. They'd click play, they'd go away and come back 24 hours and get the answer to that. That was the old world, because it used to have to do lots of joins, lots of aggregations, and lots of work on that on-premise system that I talked about. In these days, no one's waiting 24 hours to get an answer to that question. They need an answer to that question in usually seconds. So that's kind of where joining is actually a very difficult thing to implement. And that's where Snowflake and some of our competitors are focused on those kind of queries and answering those really quickly. So you're 100% right to say that different technologies suit use cases a bit better, right?
It's going through my head right now of I used to work at GoDaddy as a support engineer on the phones, a lot of troubleshooting, but it was also sales and support. So we would have to know our metrics at all the times, or like our call times, those type of things, how long we've had people on hold, and they were all different systems. And I remember that we would have to run, as I went into like leadership there, we would have to run these trying to get all the information from so many different places and manually having to put them all together and comparing them. And it would take probably a whole day before like we couldn't know yesterday's numbers until halfway through today. And as you were talking about that, I was like, oh, that would have been so cool, because they did have Tableau, and things have changed. I haven't been there for like over 5 years.
Yeah.
But it was where it still Tableau wasn't gaining all of the information or joining the information. Or I'm curious if Snowflake or I would think just the way you explain it, Snowflake would be able to maybe see of, hey, if their sales are down as a metric, day over day or month over month, that if their hold times are longer or they're not on the phones as much, their availability is lower, we could easily see a correlation there. And I would think that the way you've explained Snowflake, that is something that they could do as well.
100%. That's actually the biggest part of my job. I walk, and I'm not going to name any, but I walk into big organizations in Australia that are still operating in those silos. We call them silos, where they have a marketing team over here doing something in their area, and they have a help desk over here troubleshooting customers. They're using their own systems. And then they have a promotion team over here dealing with some other stuff. And then there's someone on the phone that's talking to a customer. A customer says, I got this promotion, but I didn't get the refund. They say, okay, I need to know, did this person call before? I've got to go over there. Did this person actually transact that with that promotion? I've got to go over to the transaction system. They don't have what the common term is a single source of truth. So half of my job is convincing people to invest in the single source of truth. And companies that do this well have invested in bringing all that data into Snowflake. But then the help desk center says a customer calls up with that exact complaint. When they then click through and drag and, let's say, drop to Anthony Schneider, they get my call history, they get my transaction history, and it's all coming from the one system, so they've got confidence in it. that is a hard case to make to a company that's kind of operating in silos, and it kind of works because there is an investment. It's not free. That doesn't magically happen. But once you meet that utopia, the experience for the customers is tenfold, right? And the experience for the employees, right? The help desk center
Mhm.
don't want to go to 50 different systems to figure out, Anthony's a customer of our online shopping portal here, but now I have to go to this other system to see if he's also shopping in bricks and mortar. That only companies that are quite far behind still operate in that way, but you'd be surprised how many still are. They don't have proper data warehousing or data analytical capabilities within their company.
Interesting, and I can really I've been a part of those conversations where it is very difficult to choose what is the source of truth and how to, let's say, a lot of times I've seen it as an API between, hey, can we get Salesforce to work with Zendesk, for example,
Yeah.
where they're connected to each other, but they're not necessarily connected to anything else that the customer is doing. Or there's tools like Common Room, which can see social media and see if they're talking about the product, if there, any interactions there. And if I'm understanding what you're saying, they're instead of having all these tools just talk to each other, they could use something like Snowflake where everything would be talking to Snowflake to store it. And then how would somebody have to go through Snowflake to see the data, or could they, for the example of Salesforce, if it's connected and going through Snowflake, they would be able to see all of the information no matter which platform they went into?
Yeah, it's a good question. And again, the terminology is confusing, isn't it? I've said single source of truth there. And this is where it gets confusing because there's a whole bunch of technology vendors who are trying to be the single source of truth. Because if you're the single source of
Mhm,
truth, everyone's using you, right? So there's I think Salesforce comes out and says we should be the single source of truth. And there
mhm,
is still going to be an element of truth to that, in the from a customer relationship perspective. They kind of are the single source of truth for that. So but what they're then saying is bring all your other data into Salesforce so that we're the source of truth for everything, because Salesforce only has one part of the puzzle, right? They don't have all the
mhm.
transactions that customer did. So to me, they're not really going to be that source of truth, as much as they would love to be. And a number of companies would like to get to that. But yeah, the idea is that the data lake or the data warehouse is probably the best position, I'll biasly say that, to be that source of truth, because it's got the ability to bring all that data together into a place. And to your point then, okay, so if I'm building a new capability within my business and I need to get the product master, so again, I'm retail and I need to get a whole list of our products, an API could be built that calls Snowflake that then pulls that product master. Whereas what a lot of customers will do is they'll go to the product catalog, build an API on that, or have one out of the box. So that's again a issue that works, having all those sources of truth within those various departments. But we are seeing customers move that source of truth into the data lake or the data warehouse. And then you've got sort of confidence that anyone around the business, whether it's operational, analytical, whatever it is using the exact same set of data as opposed to the multiple different systems.
Interesting. At what point do companies need a data lake or data warehouse then? Um, ma is it something, and yes, this really would matter on industry, so it's not necessarily the size, it matters what somebody's doing, and I do wanna clarify on that, but it's if you how to say this? A lot of times thinking about this stuff in the future-proof something if you implement it from the beginning, but sometimes that can overcomplicate things when startups are starting, for example. What time do you normally see your customers, or you talk to others in the industry, do you see them start to implement a data warehouse?
Yeah, it's a good question. Like no small business, at least not at this day and age, is creating a data warehouse from scratch. Like if I'm starting a juice stand down the street, I probably wouldn't implement a data warehouse or a data lake. If my core product as a small business is around data and data analytics, I probably would, because if I'm an e-commerce product and it's all about, well, even e-commerce, if I think about my use case around tracking what people are doing on the web, Google has some good stuff out of the box that will answer those questions and will meet the needs. I don't have to build a data lake or a data warehouse to answer those. But as soon as my questions get more complex, to my point where I need to join from different data sets, I need to use external data. So if my startup is very reliant on weather patterns, so maybe I want to join the activities of my customers with weather, that's where you would probably say, okay, I need to build a data lake or data warehouse, or I should build a data lake or data warehouse to answer those sort of questions. So from my experience, like the bulk of our customers will sit in the large enterprise group of customers. But we do have a lot of small customers because the model's completely changed. Back in the old days, if you wanted to use a data analytical appliance to ask data warehousing type questions or data lake questions, that minimum cost is probably going to be 10 or 50 grand a year or 100 grand a year, which a startup bringing in $1,000 in revenue is never going to do that. But a Snowflake, if you literally just have to ask one question a week, Snowflake can cost you $3 a week, because we charge by the second of while you're running things. So the actual proposition for smaller companies exists now with the cloud if you're using the cloud correctly, which Snowflake does. So yeah, long way to answer that question is, most companies, in my experience, if you're a small company starting out, should focus on the operations of the business. As those questions of your data become more complex, you're seeing performance challenges, you want to answer questions that the data doesn't exist within that system, that's when you'd bring a Snowflake in and you'd start looking at data lake or data warehouse patterns.
Interesting. And I feel like it's almost re-asking the question in a different way, but I think the answer will be similar, but understood in a different way. Of what do you see people's biggest pain points when they decide to set up a data lake? Like what are the biggest pain points that you see that the data lakes solve?
The data lake solves the problem of bringing all that data together and being able to join it together. The biggest challenge to doing that is the technology. And that's where we're seeing good growth. Not saying that we're a click a button and it all magically works, but what a lot of people do is they go to one of our partners like Amazon, because we've got overlaps with products, and they have to learn a whole bunch of things. They have to know what an EC2 instance is. They have to know what glue is. They have to know what this is. They have to know how blob storage works, how role-based access within that works. It's actually that can take people years to get upskilled in that. Snowflake does require skills, don't get me wrong. It requires the ability to write SQL, and there's a small element of administration on the Snowflake platform that's needed. But that's skill that we have fundamental courses that last 5 days, and you've got the basics to start to build that platform and use that platform. Whereas I guess building a data lake, I call it a build your own data lake versus a data lake where a lot of the components are kind of out of the box. So that's what you're paying Snowflake for. So that's probably the biggest difficulty, is the skill upset. And our proposition is that the skill upset is a lot less in a Snowflake world versus a build your own data lake. Like Hadoop, I did, to be honest, I'm a bit thick, but I did like 12 months on Hadoop, and I still, to answer a simple question, I still couldn't do it. I couldn't get the thing to work. And that was why Hadoop failed. It was just way too complex. And then a bunch of companies came in and tried to package it up, but even that kind of failed. Sorry, that's a bit of a sidetrack. But yeah, it's the complexity of the technology is probably the biggest barrier to companies. And I don't want to pretend that you don't need any skills to build a data lake or a data warehouse. There are skills required to do that, regardless of the technology you use.
And that's helpful to know. I think that's something that we talked about, doing this in two parts, of like the theory base and then doing like a demo base of seeing it actually happen. And I'm really excited for that because as we've been talking, I'm having more and more ideas of how does this work, like theoretically, but then how does somebody actually implement it, especially if they have existing data somewhere or like building it. Do we have to build it from scratch? Um, and I feel like those are going to be questions that are going to be easier to see as we're demoing it and seeing how it works. Um, is there any questions when it comes to the theory of things do you think that I'm missing?
Um, I don't think so. I hope we've done a good job of explaining it. The term I haven't used is lake house. Everyone here might have come across that in marketing.
Oh,
Uh,
okay. Yeah. What's a lake house?
lake house is, to me, it's a lazy one because there's no real life equivalent. You know, my examples of the lake and the data warehouse being a physical warehouse. We all know what a lake house is. It's something rich people have by the lake and they go out. There's,
Yes.
there's no analogy to data analytics with that. I mean, maybe it's a shiny thing that doesn't work, but Lakehouse was, it's quite simple, merging those two together, a lake and a data warehouse. So let's just match the
Oh,
word. That's all that was about. The idea of it was that I can have the benefits of the data lake, which is data in a raw format, and I can have the benefits of a warehouse, which is data structured into data types, and that I can combine the two together. So I'm not going there Hadoop to my data lake, and I'm going to Snowflake for my data warehousing requirements. So I think it was actually a term that was coined by one of our customers. I think it was Jellyfin back in, I forget what year it was, but 2015, or a long time ago. But effectively, they said, we're using that pattern I talked about, which is the data lake. We've got data in its rawest form, so I can always access it in its rawest form. But we've also got data warehousing in that we've got it in a defined schema that we can start to use. So that's Lakehouse. Just
interesting.
if anyone was wondering about that terminology and where it fit in between the lake and
That's
the warehouse.
that's good to know. And Todd said that they used their lake house was called the camp.
Okay,
Yeah,
that's
yeah, I
interesting.
like that.
I
I
like
like
that.
that.
The biggest thing I'll say to customers that are going on that journey is think about the name. 90% of my customers have a name for their lake or their lake house or their warehouse, whatever you want to call the patterns they're implementing. And they call it, 90% of them call it EDP, Enterprise Data Platform, or EDW, Enterprise Data Warehouse. Everyone in the business hates that. It's boring, it's an acronym, and it gets people hate it because where's that data? It's not in the EDP. And then EDP gets a really bad name. It's a little bit of marketing, but I think giving your Snowflake platform, your Lake platform, a good name is it gets people interested because they're like, what is that? I want to know more about that. If you hear someone uses the term EDP, you go, whatever, tech idiots, I don't care about that. But if they use a term like I don't know, I had a customer call it Aspire. Everyone around, what's this Aspire thing? I want to get on Aspire. So a little tidbit there for anyone going on the journey. Naming of your data lake is something. Don't call it an acronym, a 3-letter acronym, and definitely don't call it EDP.
To go back a little bit, you mentioned like there are certain skill sets that even with implementing Snowflake that individuals need to have to implement it. I'm curious about uh, job titles that may use it, or like who in the company would uh, do you normally talk to help set it up? Like, yes, there's of course like your higher ups that may be like the department head or CTO or those type of things, but who is actually implementing this and going through these processes?
That's a good question. That's a really good one because this even confuses me. Someone introduces themselves and they say, "I'm an analytics engineer." And you go, "Oh, that's a new one. I haven't heard that." So typically the roles involved. So there's usually I'll go with the most obvious one, which was my background, which is a data engineer. I think that's a well agreed upon terminology these days. It used to be called an ETL engineer. Remember I was talking about ETL? So you used to be in charge of the data transformations. But now you're not doing ETL, or that's a pattern, right? So they've changed it now to be more of a data engineer. And the data engineer is probably one of the largest personas that we work on, because they are often involved in defining the rules and writing the code that cleanses that data, that joins that data, as an example. So they'll be involved in almost any project that brings new data in. Some people split out. The data engineer is sometimes also in charge of connecting to the source systems, but often large organizations have a dedicated role to that, which will be an integration engineer or someone in charge of integrations. So they'll be the one that speaks to the source system person and brings the data in. Sitting above that, which was another role I had, was around architects. We've talked a bit about architects. So just like you have architects that design houses, you have architects that design the data platform or the data pipelines. And what I talked about patterns there, about how we load data and how we transform it. Someone obviously has to have experience in that. And that tends to be a role that you'll see, which is data architects. Sometimes enterprise architects at a high level have that skill. But anything with architect in its role that relates to data will tend to know how we're going to implement Snowflake or whatever platform you're choosing to do that in. Data modeling, if you've come across that term. Have you come across that?
Yeah. But do explain it. Do explain it to us.
Data modeling used to be a role in itself. What used to be really important with archaic, I say archaic now, let's call them legacy technologies, was how the data was put into different tables, like I said before. So if you did that big fat table, some platforms would hate that. If you did what would be referred to as a dimensional model or a star schema, some platforms insisted you do that. Because of all those complexities and the way you store data was so important, that used to be, in at least large organizations used to be a dedicated role, and it still is in a lot of organizations, because don't get me wrong, it still has an importance as to how data is stored. But what I'm seeing in the industry, and I see it in a lot of organizations, even big ones, is that the data engineer now has that responsibility. That is a key skill set that they should have, to say, this use case is calling for this type of data. This is the way I should construct that data, or I should model that data, is what we would say. So that's kind of where the data model fits in. Other key roles, you've got your analysts. So you'll have a data analyst. They're the ones that know the business requirements. And this is actually, if I have one thing for anyone learning, this to me is still the key role, regardless of anyone selling you AI dreams. The key thing that you should focus on, and why I thought I was quite successful in my career, even as a data engineer, was taking a business requirement through to the technology, or or being able to analyze the data, understand the data that met that business requirement. So that translation of business speak to tech speak or data speak is, to me, still the most important role. Any organization that doesn't have people that have that skill, that's where things go wrong, because you get a requirement which is, show me all the customers who are unhappy. That's the business requirement. If no one can translate that into the data element, someone might write the code that says, show me all customers that haven't shopped in 2 weeks. Are they unhappy? Maybe maybe they're going on holiday. So that translation as to how we answer the business question in the data platform is very important. And that tends to be where analysts fit in, BI analysts or any of the analyst roles. But I think a data engineer, anyone embarking on the bringing data in and transforming it, that has that skill set, is highly sought after as well, because they can still translate the very highly technical terms of building a data platform with the business requirements, that why they're doing it in the first place. So yeah, that's kind of where the analysts fit in. Some of those analysts don't have the skills that a data engineer has. I'd see most analysts these days are getting the skills, the coding skills, from a SQL perspective. So SQL to me is still very important to be able to code in that. But a lot of analysts maybe just interact with the BI tools that we talked about before, Power BI. They just drag and drop data in and use Tableau to form the SQL queries behind the scenes.
It's something that is just, I was blanking, so I just Googled it. Power BI, business intelligence. I was just like completely blanking while you were talking about that, what BI meant. I was like, and it totally makes sense. It was just a complete blank there. Thank you for
Yeah,
going over the job titles because I think that's also very interesting to think about if people are like, hey, this sounds really cool. I want to do something like this. It can be hard to learn about like if I wanted to do something like this, it sounds really cool. Like what job title would I want to go for
yeah,
or what type I would want to learn because a front end engineer may do some it's going to be completely different and even a back end engineer is so broad
yeah.
that knowing data engineer or analyst or those type of things is very helpful to know about. We talked about this briefly when we were setting up the call, and something that I'm curious if you. I liked that you mentioned translating business to data, but for so I guess two questions. One, do you have any suggestions on where people can learn to do that better? But then the question I meant to ask was also do you have any words of wisdom of people looking for jobs or wanting to get into this industry, something you might suggest?
Yeah. I mean, the first one, I don't have a great answer for that particular skill set. I think playing a role in business, in any business, is going to give you that. My personal experience was to start out as a support engineer. And a lot of people might balk at that. And I was up at 2 in the morning sometimes. A data pipeline had broken because someone in the source system changed something, which wouldn't happen in a data lake, right? But I hated the role. And some people love support, don't get me wrong, and it is a very important job. In fact, I think it's one of the most important jobs. But it did give me a lot of those skills because what happened in that support role is a business person said, my report looks wrong. This metric's coming out wrong. It required me to delve in and kind of work my way from the start of the problem to the end of the problem. And in doing that, I learned a lot about what that person who raised the ticket from the business wanted, what the data engineer was doing, which sometimes was crazy, and then marrying that together. So I think I spent 5 years in that role in the start of my career getting, I think it was about £20,000 in the UK, which basically I was eating $1 sandwiches every day. It was rough, but I do think it was pivotal in my career. I don't think I would be as successful or know what I know now, having not started in that role. So a lot of people and my generation's part of the problem. I think the millennials, we want to jump straight into the high paying job with all the cool stuff. Yeah, I still think you need to start out in that role to get that skill set to make it to that role. So that might be a suggestion there, is to not balk at those roles that are saying, I don't want to do that in the future, because they could be very important stepping stones into the role that you eventually want. I forgot the second part of your question.
I
Sorry.
think you kind of answered it too of words of wisdom of people that want to get into the role. Because, yes, the first question was like, how do you learn to translate from business to the data? And I think your answer of being a support engineer is a great way and a great stepping stone. So I think you kind of started answering the second question as well of any words of wisdom or suggestions for those that are interested into getting into this field.
Yeah. I think hands-on is also, again, I wouldn't say focus everything hands-on. Some people get obsessed with learning the code and they want to be the best coders. And that works for some people. I'm not a particularly great coder, but I still think that is an important journey to go on. So a lot of the cloud providers and Snowflake and others give trial credits, and a lot of the universities and that nowadays have programs, as do we, to give you a platform to start to do things on. So if anyone wants to sort of learn Snowflake, jump on the Snowflake site. There's a trial there. It gives you free credits. And then my biggest reference would be to our quick start guide. Look for a quick start, getting basics of Snowflake or getting started on Snowflake. And it is important to do some of that just so you get a feel for how things work if you're starting completely from scratch. There's so many free courses out there these days, which is great. There's a really good wealth of knowledge on the internet.
It looks like I'm trying to see if there's the getting started guide. Yes. So I'm going to put that in the chat too. and I'll post afterwards and make sure that's included. But
Cool.
that really does take a lot of the questions that I had, especially since we were talking more about the theoretical. And I am excited that next time we will get our more hands-on, like you were talking about, and seeing what we can do there. Is there anything you want to add before I end our stream?
No, I don't think so. Probably, I'm actually quite happy that we haven't talked about AI, because every conversation I have, the term AI comes up. In the context of what we've been talking about, the only thing I'd say about that is people embarking on their career, don't worry. There's plenty of jobs. AI is not taking our jobs. I think AI, to me, should be seen as an accelerator. Snowflake in itself has a lot of AI capabilities now. So what I mean by that is, in the old days when I was building a demo, which was a geospatial demo, which showed all the live locations of trucks, back to my earlier example, I would go to the Google documentation and I'd say, Snowflake, geospatial function, how do I build a polygon that shows me all the trucks within that location? And then I'd spend probably 30 minutes or an hour trying to construct that query and paste it into Snowflake, run it failed, run it again, it failed. So to answer that question would take me an hour. But now with things like LLMs and Cortex in Snowflake, I would jump into Snowflake and I'd say, I want to write a query that builds me a polygon that shows all the trucks within a geospatial boundary around Melbourne, Australia. What it'll do then is it'll write me that code so I don't have to search for it. But ultimately, there still needs to be a human looking into it and saying, is that correct? Have they made the joins correct? Have they done that correct? So to me, I think knowing the business requirements, what's the problem I'm trying to solve, as I mentioned before, is important. And AI will always be an accelerator that stops me trawling around in documentation for hours. So that's probably the only thing I'll add in if we talk about the kind of AI LLM space, which is all hot topics these days.
I feel like we could also do that in the demo of like, hey, like how would we use an LLM as
Yeah,
part of this? Because something that I've learned even becoming like a full stack developer is yes, AI can assist me with being able to figure something out and it may help me like get to the next step, but it's not always going to understand all of the code or know the full outcome, and you always have to double check it. So
yeah.
I find it as a very, very useful tool, but not the answer to everything.
No, maybe one day it will, Jen. Who knows? But yeah, definitely not today, and probably not in my experience.
Well, thank you so much for your time today, Anthony.
No problems. Thanks
Bye.
for having me. See ya.